All right, today we are going on a journey. It's a trip you take multiple times a day, every single day, but you probably never really think about it. We're going to follow our food as it makes its way through one of the most brilliant and complex systems in the entire body, the gut.
Have you ever actually wondered what happens after you take a bite of, say, a burger? It's not just a simple slide. No, what you're looking at is a super sophisticated 15-foot-long processing plant. Okay, let's dive right in.
So, our food's great journey kicks off the second it passes your lips. The whole point of digestion is to solve one huge problem, and it uses a two-pronged attack to do it. A mechanical breakdown, through physical movement, and a chemical breakdown, using some seriously powerful secretions.
At the end of the day, the food we eat, a steak, an apple, a slice of pizza, it's all made of these giant molecules that are way too big to just pass into our bloodstream. So the entire mission of the gastrointestinal tract, or the GI tract, is to just dismantle them piece by piece into tiny little molecules our body can actually use.
The first few stops on this tour are absolutely critical. First, in the mouth, chewing gets that physical grinding started, while our saliva immediately starts the chemical assault on sugars. Then, the esophagus is basically just a transit tube, a muscular highway pushing the food down into the stomach. And this is where things get really intense. The stomach is a muscular churner, just mixing everything with potent acid and enzymes until it's all a soupy paste we call chyme.
Okay, so from the stomach, that chyme moves into the main event, the small intestine. And to really get how this organ works its magic, we have to zoom way in and look at the incredible architecture of its walls.
You know what's fascinating is that from the esophagus all the way down to the rectum, the wall of the gut has the same basic four-layered structure you're seeing here. You've got the mucosa, the submucosa, the muscularis, and the serosa. It's this elegant, standardized design where every single layer has a very specific job to do.
First up, we've got the mucosa. This is the inner lining, the layer that's actually in direct contact with your food. Think of it as the front line. It's covered in these specialized cells that do two things. They secrete digestive juices, and more importantly, they absorb all those precious nutrients once they're finally broken down. Right underneath that, you'll find the submucosa. You can think of this as the support and supply layer. It is packed with blood vessels, all ready to just whisk away the absorbed nutrients to the rest of the body. And it's home to a super dense network of nerves. Now hang on to that thought about the nerves. We'll be coming right back to it. Next is the muscularis, which is the absolute powerhouse of the gut. It's got two different layers of muscle, one that goes in a circle and one that runs lengthwise. And their perfectly coordinated contractions are what mix the chyme and push it forward. That's GI motility in action. And finally, wrapping the whole thing up, you have the serosa. It's basically a thin, tough, protective skin that holds everything together and gives it a slippery surface so it doesn't create friction with your other organs. And this diagram just shows so brilliantly how it all fits together. You can see those distinct layers, right? But look closer. See those yellow networks woven right into the walls? Those are the nerve plexuses. There's one in the submucosa and another one nestled between the muscle layers. This right here is the gut's built-in command center. So those are the layers, but the main goal, the whole point of the small intestine, is absorption. And to be as efficient as possible, the body uses this incredible trick to maximize its surface area. So how much area are we talking about? Get ready for this. About 300 square meters.
That's right, it's wild. By using this clever system of folds, and then tiny finger-like projections called villi, and then even tinier projections on those called microvilli, your intestine manages to pack the surface area of a tennis court inside your abdomen. It's an amazing design to make sure not a single nutrient gets left behind.
So we've got the structure, but how is all this activity controlled? I mean, this isn't just random sloshing. The gut is actually run by its own highly sophisticated, built-in nervous system. A system so complex, it's often called the body's second brain, or mini-brain.
It's called the enteric nervous system, or ENS, and it's made up of those nerve networks we saw a minute ago. The most important thing to understand here is that it is self-contained. It can sense what's going on inside the gut and coordinate a response all by itself without having to phone home to the brain for instructions.
So just how complex is this mini-brain? Well, take a look at this number. 100 million.
That's how many neurons are crammed into the walls of your gut.
To put that into perspective, that's about the same number of neurons you have in your entire spinal cord. It has its own sensory neurons, motor neurons, the whole shebang. It's a complete reflex circuit hiding in plain sight.
Now, while the ENS can run its own show, it doesn't work in total isolation. The central nervous system can definitely influence it. Your sympathetic system, that's your fight or flight response, basically tells the gut, hey, not now, and puts the brakes on digestion. On the flip side, the parasympathetic system, your rest and digest mode, does the exact opposite, ramping up movement and secretions.
And this flowchart shows it perfectly. See, a change inside the gut can trigger a short reflex that's handled completely locally by the ENS. But signals can also travel all the way up to the central nervous system, which then sends commands back down in what we call a long reflex. You know that feeling when the smell of food makes your stomach start to rumble? Yep, that's a long reflex in action.
Okay, as our food's journey starts to wrap up in the large intestine, the main job switches from absorbing nutrients to absorbing water. But as we zoom back out, we start to see that the GI tract's job is so much bigger than just processing your last meal.
The GI tract is a master of fluid balance. It's a frontline defender in our immune system, housing about half of the body's entire immune force, and of course, it's the primary system for getting rid of waste. On top of all that, it maintains this crucial ecosystem of beneficial bacteria that are absolutely vital for our health.
And to really appreciate its role in keeping us hydrated, just look at this final number, 8.5 liters. That is how much fluid, from what we drink plus our own bodily secretions, your gut handles every single day. And it is so mind-blowingly efficient that about 99% of that fluid gets reabsorbed right back into your body, keeping you perfectly hydrated. It's just an astonishing piece of biological engineering.
So when you really think about it, our digestive system is so much more than just a tube for food. It's an immune organ, it's a master of hydration, and it's home to its own intelligent brain. It really makes you wonder, doesn't it? What other incredible hidden marvels are humming away inside of us right at this very moment?